Hi, today we are looking at modeling and optimization. So with modeling and optimization, in most cases, if possible, we'll start by drawing a diagram of our situation so we can see what's going on. And often with our diagram, we'll be able to figure out what other formulas will be required of us, whether we're using Pythagoras or area formulas or volume formulas. We then write an equation or equations that model our situation. We differentiate and simplify, finding our critical points in the domain, and then we'll make a sign diagram to help us solve. So we have a farmer wanting to construct a rectangular pen for their chickens. If this farmer has 60 meters of fencing, what dimensions will give the maximum area? Okay, so this is their pen. Now, because we are creating a rectangular pen, and we know that this side must be equal to this side, and this side must equal this side. We know that two sides must add up to be equal to half of 60 meters. So we know we've got 30 meters for two sides. So we could say that, for example, this side is x, and then if we know that two sides are a total of 30 meters, we could say that this is 30 minus x. Or alternatively, writing out a different way, we could say 60 is equal to 2 times our length plus 2 times our width. We divide everything by 2, that gives us 30 is equal to our length plus our width, or 30 minus our length equals our width, which is essentially what we have here. So I've put my length as x, which means my width is 30 minus x. Now, because we're dealing with area of a rectangle, we will be using area is length times width. But because we've come up with these dimensions, we can say our area is x times 30 minus x. Or expanded out, that would be 30x minus x squared. Now we want to find our critical point, so that means we want to take our derivative of this area formula. So our a prime is equal to 30 minus 2x. So we want to find where that equals 0. So we've got 0 is equal to 30 minus 2x. Move the 2x to the other side. And divide both sides by 2, so that gives us x equals 15. So we know that this is a critical point. Now we'll draw out our line graph. Now, some key points. We know the low point on our line graph would be 0, because obviously we can't have a side length that's less than 0 or even equal to 0. Where our maximum side length would be 30, because essentially 30 minus 30 would give us 0, so we can't even have it 30. So we know our domain would be from 0 to 30. Now we'll also put a critical point in there. And then we're using our A prime. So our A prime is 0 when we're at 15. So what we're going to do is look at what's happening to A prime before 15 and after 15. So if I was to substitute in, say, 10 into here, between 0 and 15, if I substitute 10 into here, that would give us a positive value. If I was to substitute, say, 20 into here, that's going to give us a negative value, which means our graph of A would be going up here and going down here, which means that this is a maximum point. So we can say x is equal to 15 at the maximum area. But we want both dimensions. We want both our length and width. But we know our width is 30 minus x. So we know that that's 30 minus 15. So our width is 15. So our dimensions are 15 meters by 15 meters. Okay, so this was a two-dimensional example. We'll look at a three-dimensional example next. We're told that we're using a maximum of 2,700 centimeters of material to make a box with a square base and open top. And we want to find the largest possible volume of the box. So once again, I'd start by drawing out our situation. Okay, so our box looks something like this. Now we're told that it has a square base. So that means that this side is x, this side is x. Probably didn't draw that to the best scale, but we know those two are the same. Now it's going to have a height that we'll say is h. Now if we look at our area of this, we know the base is a square. So our base is just going to be x squared. Now if we look at any side, our area would be a rectangle. So our base times our height. So we'd have xh for times h for this side, xh for this side, xh for that side, xh for that side. So that gives us plus 4xh. Now we're given our total area is 2,700. Now, eventually we're going to want to substitute this into another equation, and we're probably going to want to keep our x values. So I would move everything to the other side and get h on its own. So I would have 2,700 minus x squared equals 4x, or sorry, 4h, or 4xh, I should say. I now want to divide both sides by 4x. So that gives me 2,700 minus x squared over 4x equals h. Now, we're looking for maximum volume. This is a rectangular prism, so we know that's length times width times height. So we know our length is x, we know our width is x, and our height is 2,700 minus x squared over 4x. Now, we can cancel this x out with one of these. And then we'll go through and simplify a bit. So we'll multiply our 2,700 by x and then divide by 4. So that gives us 675x. Multiplying our x by x squared gives us x cubed. Divide by 4 gives us essentially minus x cubed over 4. Now what we want to do is find our critical points for this. So we've got v prime is equal to 675 minus 3/4 x squared. Now we know we have a critical point when this equals 0. So I put 0 here equals 675 minus 3/4 x squared. We'll move the 3/4 x squared to the other side. Divide both sides by 3/4. And that gives us x is positive 30 as well as negative 30. Now, would it make sense to have a negative side length? Not really, so therefore, we know we just have that 30. Now, before we do a line graph of this, we should figure out what our domain is. So, obviously, our x should be greater than 0 because otherwise we don't have a side. But we also know that if our x here is too large, then all of a sudden our volume goes to 0. So we can say our x has to be less than the root of 2,700. Or 0 is less than x, which is less than 30 root 30. Okay, so now I will draw out our line graph. So we know the starting point of our domain is 0. The ending point is 30 root 30. And we have x value of 30 in the middle. Now we know a prime, or sorry, in this case, v prime was 0 at 30. If I put in something between 0 and 30, like 10, and substitute right into here, I get a positive value. Or if I put something larger than 30 in, I get a negative value. So we know our graph of our volume is going up here and down here, so that means we do have a maximum here. So we know that we have our max volume when x equals 30. But that's not what it's asking for. It's asking us for what that maximum volume is. So what we'll now do is take our volume equation, which was 675 times x minus x cubed over 4. And we'll substitute that 30 in. So we've got V is equal to 675 times 30 minus 30 squared, or sorry, yeah, 30 cubed divided by 4. And that gives us a volume of 1,000, or sorry, 13,500 centimeters cubed. Okay, next example, a rectangle is inscribed in a semicircle with a radius of 7 root 2 meters. We want to find the maximum area of this rectangle. So once again, start by drawing out our situation. So we've got a semicircle here. And inside it, we have a rectangle. Now we know the distance from the center of the circle to the edge of the circle, which I might as well put right here, is 7 root 2, because that's our radius of a circle. It'd also be 7 root 2 from here to here or here to here. And I'm just going to label this O for my origin. Now what we can see is this creates a 90-degree triangle, so we're going to utilize that. So you know that we'll call, say, this side X and this side Y. Now, if we know these two, we can then calculate our area of this rectangle, because if X is from here to here, we know that from here to here, it's going to be 2X, so our area would be 2X times Y. And we can relate these two together with Pythagoras because we have a triangle. So we can say A squared equals B squared plus C squared. So we have 7 root 2 squared equals X squared plus Y squared. Now I'm going to rearrange and get Y on its own. So if I square 7 root 2, that gives me 49. Now we'll or sorry, not 49, 49 times 2, so that'd be 98. Now we'll move our x squared to the other side by subtracting it over. And then we'll take the square root of both sides. So we know 98 minus x squared equals y. Now our area, we know, is length times width. So in this case, our length would be x plus x, so 2x, times our width, which would be this y, which in this case, we will substitute in this equation we have here. So next, to find our critical point, we'll take the derivative of both sides. So a prime is equal to our derivative of this first part. So that would just be 2 times the square root of 98 minus x squared plus our first function of 2x times the derivative of this, which would be 1 over 2 root 98 minus x squared, and then utilizing the chain rule, multiplying by 2x. And not only 2x, but we've got minus in front of us, so we need to multiply by negative 2x. Now we'll go through and simplify this a bit. So it gives us a prime is equal to 2 root 98 minus x squared minus 2x squared over the square root of 98 minus x squared. Now, To make things simpler, we probably want these over the same denominator. So I would multiply this one by root 98 minus x squared over root 98 minus x squared. So that gives us a prime is equal to 2 times 98 minus x squared minus 2x squared, and that's all over square root of 98 minus x squared. So we'll expand this out a bit. So we've got a prime is equal to 196 minus 2x squared minus 2x squared, so minus 4x squared over the square root of 98 minus x squared. Now, we know our critical points are where this equals 0. Now, the only way this can equal 0 is if our numerator equals 0. So we're going to say equal to 0. So our numerator equal to 0. So we've got 0 equals 196 minus 4x squared. We'll move the 4x squared to the other side. Divide both sides by 4. Which gives us x squared equals 49. And that gives us x is 7 and -7. Now, once again, -7 doesn't make a sense in this context, and we should probably look at our domain. So our domain for this, we know x should be greater than 0, because it doesn't make sense to have a negative sideline. Now, if we look at our equation here, we know that we can't have 0 in our denominator, nor can we have a negative in here. And that means that x can't be any bigger than 7 root 2. So we will draw out our number line. So we've got 0, 7 root 2, and an x value of 7. So a prime we know is 0 and x is 7. If I say substitute a value like 1 into our equation, that's going to give us a positive up here. So we know it's positive here. Or if I substitute anything larger than 7, it's going to give us a negative in our numerator. So we know that our graph of A is going up here, down here. So that means that this must be a maximum point. So we know that our maximum area occurs when x equals 7. Now over here we had an equation for our area. So calculate what that maximum area is. So we've got area is 2 times x times the square root of 98 minus x squared. We'll substitute that 7 in. So I've got 2 times 7 square root of 98 minus 7 squared. And that's going to give us an area of 98 meters squared. Okay, next we have a more complex situation. We have a cable TV company is laying cable in an area with underground utilities. Two apartment complexes are located on the opposite sides of Fish Creek, which has a width of 100 meters. The company needs to connect points R and S, which this should be point R, and this should be point S, with cable. Now we're told it costs $40 a meter to lay a cable underground and $80 a meter to lay cable under the creek. We want to find the least expensive way to join our points. So first thing we're going to do is draw a more simplified diagram that doesn't have our apartments in it. So essentially, we know that we have one side of our creek here, the other side here. We know that across here is 100 meters. We have some point down here, which is S. We know that this is R. We are probably going to cut across our creek on some line here. I will call that for the time being A. I'll call this point over here U, where it's directly across. This point where it connects here, I'll call T. And essentially, we know this total distance was 1,200 meters. Which means if I say call this distance X, that means that this would be 1,200 minus X. Now, essentially, we know this is a 90-degree triangle, so we can use Pythagoras to relate these two sides to this A. So we have A squared equals B squared plus C squared. So we have A squared equals 100 squared plus 1,200 minus X squared. Or A is equal to a square root of 100 squared plus 1,200 minus X squared. Now we know our cost is going to be equal to our rate for going underwater, which would be 80 times our distance A, as well as our 40 meters, or sorry, $40 a meter times whatever this distance here is. So I can say our cost is 40 times X plus 80 times 100 squared plus 1,200 minus X squared. So we are going to take the derivative of this. I'm just going to abbreviate cost with C prime for our derivative. So we would have 40 plus, if we take the derivative of this, it would be 1 over 2 times the root of this. That 2 will partially cancel out with the 80. So we've got plus 40 over the square root of 100 squared plus 1,200 minus X squared. And then we have to take the derivative of this. So times 2 times 1,200 minus X. And then times the derivative of this. So times -1. Going through and simplifying that gives us C prime is equal to 40 plus, I won't expand this bracket out yet, but I'll multiply 40 by the 2 and then -1. So I've got -80 times 1200 minus x over our square root of 100 squared plus 1200 minus x squared Now we want to know where this equals 0. So I put 0 in here, so I've got 0 equals 40 plus, actually we can probably get rid of a plus because we've got the minus there. So minus 80 times 1200 minus x over the square root of 100 squared plus 1200 minus x squared. So I'd probably move this to the other side in the next step. So that gives me 80 times 1200 minus x over the square root of 100 squared plus 1200 minus x squared equals 40. Now next step, I'll do a couple things. One is I can divide both sides by 40, and I'll also multiply both sides by this square root to move the root over to the other side. So multiplying this by 40, or sorry, dividing this by 40 gives us 2 times 1200 minus x equals, when I divide this by 40, that gives us 1, multiplying it by this gives us square root of 100 squared plus 1200 minus x squared. Next, I'm going to get rid of the square root by squaring both sides. So that gives us 4 times 1200 minus x squared equals 100 squared plus 1200 minus x squared. That's I'm going to combine like terms. We can see that what's in this bracket's the same as what's in this bracket. So if I subtract this over, that gives us 3 times 1200 minus x squared equals 100 squared. Going to divide both sides by 3. So that gives us 1200 minus x squared equals 100 squared divided by 3. At this point, I take the square root of both sides to get rid of those squared. So that gives us 1200 minus x squared equals 10 over the root of 3. Or sorry, 100 over root of 3, because taking the square root just cancels out the squared. Now, when we took that square root, technically that gives us a positive or a negative. Now, I would probably move x squared to the other side and move this to this side. So we've got 1200 plus or minus 100 over root 3 is equal to x squared. Or sorry, equals x. As I realized I took the square root of both sides, but I forgot to get rid of x squared. Okay, so at this point, calculating two values, x gives us 1,142 or 1,258. Now, right away, we can get rid of one of these answers. We can get rid of this answer because if this was 1,200 meters, having an x value greater than that doesn't make sense. Now we'll just put this information on a number line to show that this would in fact be the value that's going to give us our minimum. So essentially we know our x, our maximum would be 0. Or sorry, minimum would be 0. That'd be us just doing a diagonal line right across, where our maximum would be us going straight across and then the whole 1,200 meters. And then we've got this point that we just had of 1,142. And if we look at C prime and substitute a value in less than 1,142, so something like 10, if I was to substitute 10 into here, I would have, say, a negative times positive, and adding the front and the value in front, that would give me a negative. And substituting a value between these two in, I get a positive, so we know we're going downwards here, up here. So we know that this is a minimum point. So we know we have a minimum when x is 1,142, but we still have to figure out the cost. So if we look back at our cost equation, our cost was 40 times x plus 80 times our square root of 100 squared plus 1,200 minus x squared. So we'll substitute our values in. So we've got 40 times 1,142 plus 80 times the root of 100 squared plus 1,200 minus 1,142 squared. And that gives us a cost of $54,000 or $54,928.22.